In this lesson, we're going to talk about how we calculate the molarity of a solution and then how we use molarity in calculations. Is molarity a simple unit or a relationship? Molarity is a relationship because it relates moles to liters for a particular solution. With molarity, we're going to do two different things. We're either going to be calculating molarity or we're going to be using molarity. When we're calculating molarity, we have to find the moles if we're not given the moles, and we plug that in. We find the volume in liters, plug that into our equation, and then we can do the math of moles over liters to find molarity. When we're using molarity, we see that molarity can be written as our relationship of moles over liters. So we can start with moles to get to liters or start with liters to get to moles. Once we have moles, we could also continue on to grams using the molar mass. This is just one relationship that we use in our toolbox to determine how to find the answer for a problem. What is the molarity of a solution prepared from 2.5 moles of KBr in 5.8 liters of solution? Remember that molarity is moles of solute over liters of solution. We are given the number of moles, so 2.5 moles of KBr over 5.8 liters of solution. We can divide and find 0.43 molar for the solution. Note that we are given the molar mass, but we don't have to use it. Just because the information is there doesn't mean we have to use all information given in the problem. Focus on the units and use what you need. What is the molarity of a solution prepared from 32.5 grams of NaCl in 250 milliliters of solution? Unlike the previous problem, we aren't given moles and liters. We're given grams and milliliters. So there are additional steps that we need to do before we can find the molarity. Molarity equals moles of solute over liters of solution. We need to take the mass of our solute, 32.5 grams of NaCl, and we're going to use our molar mass, 58.44 grams per mole of NaCl, to find the moles of NaCl. We'll plug that into our equation for molarity. Then we need to find the volume of the solution in liters. So we have 250 milliliters of solution. We use our metric prefix conversions to convert from milliliters to liters. Put the 1 with the prefix and put the meaning of that prefix. So the meaning of milli goes with the base unit of liters, 10 to the minus 3. We do the math and get 0.250 liters, which we can plug into our molarity equation, and then solve for the molarity and get 2.28 molar. Next, we're going to see how we use molarity to find an answer. What mass of LiF is in 72.9 milliliters of a 3.5 molar LiF solution? In this case, we're given the molarity. We're not finding the molarity, so we're going to use the molarity to solve the problem. First, we want to rewrite the molarity to show the relationship clearly. 3.50 moles of LiF per 1 liter of solution. Now it's much easier to see the relationship. We have 25.94 grams per mole, or the molar mass of LiF. That's a relationship. 72.9 milliliters is a simple unit. So we're going to start with that. 72.9 milliliters. We need to convert that to liters because we see that molarity has liters in it. We need those units to be the same. Put the 1 with the prefix. Put the meaning of the prefix, 10 to the minus 3, with the base unit of liters. Milliliters will cancel, and at this point I would have liters. Now I want liters on the bottom, so I'm going to put moles on top because I have a relationship between liters and moles. And that's my molarity of the solution, so 3.50 moles per liter. Liters will cancel out. I know I need moles on the bottom of the next step, and the relationship I have that it has moles is the molar mass. So I have grams per mole, and put 25.94 in for the grams. Moles will cancel out. And now do the math and get 6.62 grams of LiF. While there are more steps here, notice this is just like the dimensional analysis problems we did earlier in the course, and we're just using molarity as one of the relationships to help us get from what we're given to what we're trying to find. What is the mass of solute in 150 milliliters of 2.65 molar acetic acid solution? We're also given some information about acetic acid, such as the chemical formula, the molar mass, and the density. First, I'm going to rewrite the molarity as a relationship, so 2.65 moles over liters. I see I have a relationship with the molar mass and a relationship with the density. The only number I have as a simple unit is the 150 milliliters. I'm going to start my problem with the 150 milliliters. I know milliliters needs to go on the bottom, and I want to convert that to liters because I see that molarity has units of moles per liter. You may see that we have the density of 1.05 grams per milliliter, which also has milliliters in it. But that gets us to grams of the solution, not grams of my solute. The density is for the solution. I put milliliters on the bottom and liters on top, and put in my 1 with the prefix and the meaning with the base. Cancel out milliliters. Then I need liters on the bottom, and moles will go on top because I'm using the relationship for my molarity. 2.65 moles per liter. Liters will cancel out. Next, I need moles on the bottom and grams on top. And I have 60.05 grams per mole. Moles will cancel. And I find that I have 23.9 grams of solute in my solution. So A is the correct answer.